Welcome to MySci Unit 3, Make It Go. This is a kindergarten grade physical science and engineering unit where students explore a handmade toy called a Galimoto. They will investigate how objects move and engineer a Galimoto toy of their own. Let's take a look into the unit at a glance. This unit covers 2 kindergarten grade physical science standards along with engineering standards to develop a model and analyze tests of objects made to solve a problem. Each of the next generation science standards correspond to a Missouri Learning Standard listed in parentheses on this chart. If you'd like, take a moment to pause the video and review them. This unit is divided into 2 sections. Each section has a driving question designed to reflect what we anticipate students would naturally ask through the learning process. After launching with the anchoring phenomenon, Section 1 includes 3 lessons and Section 2 has 2. Overall, the unit should take about 25 to 29 days to complete. The anchoring phenomenon is a boy builds a Galimoto toy that can move in different ways. Students will explore what a Galimoto is and how they can make it move in different ways. They will then engineer a Galimoto toy of their own and analyze each other's projects. The driving question for Section 1 is, what makes Galimotos move? Students connect to the anchoring phenomenon by doing a read-aloud about a boy who makes a Galimoto. Students discover that to change the speed or direction of an object, you can push or pull it. The section concludes as students investigate and use evidence to explain what happens to an object's motion when toys collide. Through the storyline in Section 1, students gain an understanding of these standards-based big ideas. We can move objects with a push or a pull. A force is a push or a pull. Pushing or pulling on an object with different strengths and direction changes its speed, direction, and position. A collision is when 2 things bump into one another. This can change the motion of the objects. A harder push makes something speed up more quickly. Introducing the anchoring phenomenon in Section 1 combined should take about 14 to 16 days to complete. The driving question for Section 2 is, how can we make a Galimoto? In this section, students connect to the anchoring phenomenon by engaging in the engineering design cycle. They brainstorm designs for their own Galimoto using the available materials. Students develop, model, and test how their Galimotos move using pushes and pulls. The section and unit conclude as students communicate their results with peers and self-evaluate their Galimoto designs. We'd love to see the Galimotos your students make. Through the storyline in Section 2, students gain an understanding of these standards-based big ideas. A problem can be solved through engineering. Engineers ask questions, make observations, and gather information to help them solve problems. An idea for a design can be conveyed through a simple sketch. Models of designs can be built, tested, and analyzed. Section 2 should take about 11 to 13 days to complete. Our team here at MySci hopes you and your students enjoy Make It Go and designing their own Galimoto toys. We look forward to your feedback. Happy MySciencing!